everyone. I am Bhavin Valdota and I am here to explain and demonstrate to you about our idea and Smart India Hackathon 2023. My team name is AreoSolutions and I am the leader. We all are from Viswakarma University, Pune. So let's get started with our topic. The topic which we chose this year is about AI based automatic alarm generation and dropping of payload at a particular place through a drone. This topic was given by Ministry of Defense and the theme of the topic is disaster management. More on the topic. So, if I can give you an overview about the topic, what we have to do exactly is we have to create a drone which can automatically fly from a source to a destination location, handling all the obstacles, and also in between in the disaster area if it identifies a human being from the height of 50 to 100 meters, the alarm will be generated automatically. This is one of the case, and the second one is to deliver payloads. So it is also helpful in a disaster management system where if some human beings or some peoples are stuck in a disastered area and if no helicopter or rescue team can go, then till that time we can make use of drones and supply food, clothing and necessary aids till the rescue team finds out a way to reach to them. The technology stack which we are using in our development are drone technology, camera, artificial neural network, payload delivery management system as I told you, and Unity software, deep reinforcement learning, deep learning, and Raspberry Pi at the last. So if I start explaining about our development phases, we have divided the whole project in 4 development phases. The first phase goes as creating a virtual environment. Creating a virtual environment, why you ask? This environment has been created so that we can set up a drone simulation system and test our drone before applying it to the real world. The second phase is the most efficient phase where we are going to create a DL algorithm more on deep reinforcement learning algorithm which can make our drone fly automatically. Then the third phase comes as creating human detection model, object detection model, and lastly payload dropping model. And then the fourth stage, the final stage is for testing. So let me show you what we have developed till now. As you can see here on the screen right now, this is the environment. This is one of the environment which we have created for our drone testing and purpose. The rest of the environments we are creating in using Unreal 5. That means that we can get as realistic as possible. So our model is as accurate as possible. Let me show you how it feels like. So as you can see here, this is the way our environment and drone simulation looks like. This is the third person view, which will not be like this is for our convenience, but the original view would be like this. So this is the drone camera. On this camera we are going to attach the object detection and the human detection model. So it is easier to find out where exactly someone is stuck. And once they found out a human being or some people's stuck in a disastered environment, automatically alarm generation will be enabled and the rescue team may know that there are some people stuck in the particular area. This is the environment which we have created right now. This is only for the testing phase and we are going to create more environment as I told you. So this was our virtual environment and the second was about DRL models. So right now I have created 2 of the models for the practice purpose. Let me just show you. This is the first model which we have created. The blue box which you are noticing is it's our agent and the yellow one is a goal. So our agent needs to reach the goal in a particular given time. So as you can see here, our agent is moving towards the goal. You can see I am not doing anything, it's automatically moving towards the goal. What we can do here is we can move this goal. See, so if I move this goal, you can see our agent is also starts moving towards it. So as you see, our agent also starts moving towards the goal. So as you saw, our cube was moving in the two dimension, that is forward, backward, left and right. But now this is a new demonstration where our model or our agent can also jump to reach its goal. This is the initial stage for our drones because our drones also needs to go higher and lower depending on the obstacles and the environment to reach towards its target. So this is our deep reinforcement learning model right now. And what I mean by deep reinforcement learning model, the reinforcement learning model works on these steps that it observes the environment, it takes a decision, then that decision is converted into an action, and the action is then converted to a reward. And this cycle goes on. If I may give you an example, the simplest example can be of a dog. When you want to train a dog, if like you want to make him sit, and when he sits or does that task particularly successfully, we give them a reward. That means it can be a food or anything. So it's similar to our AI with what we have used for AI. If the AI goes towards the goal without hitting any obstacles and does the particular task correctly, we give him a positive reward. And if it does not does the task correctly, it gets a negative reward. So it's like bribing them. So they are bribed to go and get more rewards. And so this neural network is developed in the way that it may always want to get the highest score. This is what the deep reinforcement model we have trying to we are trying to develop for our drone system. So once, as you saw, our model or our agent was jumping to reach its goal, similarly we are trying to make a model for our drone which will try to block all the obstacles and reach towards the goal. Right now what you can see is the spear as the goal object, but instead of spear we can also add our particular location or the coordinates, so our agent may go towards that coordinate, dodging all the obstacles in the between. And the next model is we have to show is about human detection system. So this is our human detection system which we have used YOLO 3 model right now. Let me just show you the demonstration. So as you can see, it recognizes me as a person right now, and if I try to go back, as you saw, it recognizes me from a far behind, that is approximately 5 meters away from the place where I'm sitting right now. Being a laptop webcam camera, if it recognizes me from 5 meters away, then we are hoping that a good camera can get us accuracy from 15 to 20 meters at least. And if we try to increase our model, so as I told you, this is YOLO 3 which we are using right now. We are trying to develop a model using YOLO v4. If that goes successfully, we are thinking that it may our model also may recognize a person or any object from a distance of 50 to 100 meters, what is there in our problem statement. So as you saw the demonstration of human detection, we are also working on the model where it can detect objects as buildings, cars and trees. What all the these different types of objects which are which drone can capture from a height of 50 to 100 meters. Also, if our human detection fails in some area because some obstacles have overcome the person, then we are also trying to use a heat system, so it can capture a human heat, and also on that it can uh, like generate an alarm if he sees a human being stuck in the disastered area. Moving ahead on our topic was given to develop a software, but we are trying to also integrate it with the hardware to get a proper solution. So to integrate our software with the hardware, we are trying to use Arduino system or Raspberry Pi. These are the SBCs or single board computers. These are programmable computers which we can program according to us using our models and attach to the main motherboard of the drones, so they can start acting as we programmed them. The use cases for our software can be, as I told you, one for the disaster response. Our software can play a crucial role in disaster response scenario. It can identify humans, automatically generate alarms to alert the rescue system. Also, it can provide the food and aids. The second one is automatic object recognition. It is not only used for disaster management areas, but also in technologies where they need to they need to make use of drones and like identify objects from air. Also, the last one is payload dropping. This can also be used for delivery, as Domino's pizza delivery or Amazon deliveries, with the help of drones, which may be more faster and efficient. Also, the dependencies or the showstoppers which we have is technical challenges. What challenges can we face? We can face technical challenges in optimizing our flight path and fine tuning the DRL algorithm. As I told you, we are still working on our DRL algorithm because we don't want that we give a drone a particular location, it never reaches the particular location having a payload attached to it, so that can be costly. So to optimizing our DRL algorithm, we are working harder on it. The second one is the hardware and software dependency. As I told you, we are going to use Raspberry Pi. So the Raspberry Pi hardware and the drone hardware should be compatible, or the Arduino hardware should be compatible, which we are trying to help or get emphasize on. Large field of and at last, moving ahead, this is my team of 6 members, where I am leading the team. As I told you initially, we all are B.Tech third year students studying in the Viswakarma University at Pune. And we all came from a background from artificial intelligence and data science stream or computer science stream. I will provide all of our LinkedIn profile IDs in the description below, so you can stay connected with our project. Thank you.